Alright, in this video we will graph another rational function, specifically this one right here for number 3. I'm thinking this one should be relatively easy because there's nothing to factor or anything like that. It's pretty simple. So, let's talk about the vertical asymptote. The vertical asymptote is going to come from the denominator, setting the denominator equal to 0 and solving. So if I set x plus 1 equal to 0 and solve, I'm going to subtract 1 from both sides, and I'm going to get x equals negative 1. So that's my vertical asymptote, will be x equals negative 1. So I'm going to go ahead and graph that right now. Okay, there's my vertical asymptote at negative 1. Now, horizontal asymptotes are slightly more complicated. If you want to know what the horizontal asymptote is, you need to look at the degree. You need to figure out which one of these three situations you're in. If the degree of the numerator is less, then the horizontal asymptote will be y equals 0. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote will be y equals a over c, where the a and the c are the leading coefficients of the numerator and denominator. And if the degree of the numerator is greater than the denominator, then there is no horizontal asymptote. There might be a slant asymptote, which is not the case this time, so we're not going to worry about it. So going back to the problem here, we need to ask ourselves, what is the degree of the numerator? What's the degree of the denominator? Well, the degree of the numerator is 0 because there are no x's up here at all, just a constant. There are 0 x's. The degree of the denominator is 1. All right, you can think of it as x to the 1 power, or you can say, look, there's 1x right here. All right, so 0 and 1. So that means the degree of the denominator, well, okay, I usually say it in terms of the numerator. The degree of the numerator is less than the denominator. So what did we say would happen? Well, if the degree of the numerator is less than the degree of the denominator, then y equals 0 is the horizontal asymptote. So that means for this problem, the horizontal asymptote is going to be y equals 0. So we can go ahead and write that down, y equals 0. And we can also graph it. Y equals 0 is the x-axis, so we can just graph that. Alright, so there's my horizontal asymptote. You can kind of see behind this gray screen, which is not going away for some reason. Now we need to start plotting some points so we can see exactly what this graph is going to look like. And I'm wondering, will this giant GO ever go away? Okay, it finally went away. So we need to plot some points right now. So what we're going to do is make a table of values. And I'm going to make my table of values right here. I don't know why I made it that big. I'm not going to do that many points. All right, we need at least 3 values on the left of the vertical asymptote and 3 values on the right. So here are the values that I'm about to use. The vertical asymptote is at negative 1. Always use the decimal to the left and the decimal to the right. So if I go a half a square to the left, that would be negative 1.5. So I'm definitely going to use that, negative 1.5. If I go a half a unit to the right, that's going to be negative 0.5. So I'll definitely do that. Now, so I've got a value just to the left and to the right. So I need 2 more values on the left and 2 more on the right. So I'll go ahead and do -2 and -3 on the left. And on the right, I'll go ahead and do 0 and 1. So this gives me 3 values on the left and 3 values on the right. So I will go ahead and put this equation into my calculator and see what I get. So 2 over x plus 1. Okay, I'm going to stay in ask mode for the decimals anyway. So decimal wise, I said I wanted -1.5, which, you know what, I'll just do it down here. So -1.5, that's -4. Okay, I also wanted -0.5. That's +4. Okay, the rest of these, I think it would be easier, to go ahead and switch out of ask mode and back into auto. Okay, so I wish I would stop doing that. So I need -2, -3, 0, and 1. Okay, so at -3, I've got -1. At -2, I've got -2. At 0, I've got 2. And at 1, I've got 1. Okay, so now it's time for me to plot all of these points. So -1.5 is -4. So here's -1.5, comma, -4. All right, -0.5 is +4. So -0.5, +4. -2, comma, -2 would be here. -3 is -1. So here's -3, -1. So that gives you a feel for what's happening right here. And then I've got 0, 2 would be right here, and 1, 1 would be right here. That gives you a feel for what's happening right here. So I'm going to go ahead and draw in both branches off camera. Okay, so here is what your graph should look like. Now we're ready to talk about the domain and the range. All right, so the domain, normally when a graph goes left forever and right forever, we just say -infinity to +infinity. However, there is a vertical asymptote here, which is not being touched. So we have to break up the domain into 2 parts to avoid the value of -1. Okay, so looking at the x values, this graph goes from -infinity right up to -1. So that's going to be the first part of my domain, will be -infinity to -1. I'll use a round parenthesis because it never touches -1. It's the asymptote. And then union. And then we have to pick up on the other side of the asymptote and go from -1 to infinity. All right, so -1 to infinity. That way, we have not actually touched the asymptote at -1. The range is going to be almost the same thing, but range goes from bottom to top. So the range is going to go from -infinity to 0, all right, because that's where the asymptote is. So -infinity to 0. Union. And then it picks up after the horizontal asymptote, and it goes from 0 to +infinity. All right, so there's the range. We had to skip over the asymptotes. Now, increasing and decreasing intervals. Well, as you look at this graph, if you were traveling along this path from left to right across the graph, for part of the graph, you're going to wind up going downhill, and for part of the graph, you'll be going uphill. So look, for this part of the graph, that's too big. For this part of the graph, we're going downhill, down, 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 down. So that is decreasing. But then this part of the graph over here, I have to pick up on this side, and again, I'm going from left to right, I'm going down, 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 down. So we were actually decreasing the entire time. Okay, so the entire domain is decreasing. So we're basically going to wind up just repeating this again and saying decreasing from negative infinity to negative 1 union negative 1 to infinity. All right, it's decreasing over the entire function, and that's where the function goes. Like, that was the domain. Now, where is it increasing? Nowhere. So I'm just going to put none. And that is the end of that problem. That's all we were asked to find for number 3.